Hello, my name is Nathan Zellner, and my partners for this project were Daniil and Darren. This project is our ECP2 for ECE 285, and this is a guitar tuner circuit. And right here it's powered by a 6-volt power supply. So the purpose of this circuit is to assist the user tune his or her guitar. And so there are three main parts to this circuit. The first part down here is a square wave generator, which we use to generate 6 ideal frequencies, and those frequencies correspond to the 6 strings of a guitar. So this part of the circuit, it consists of a 555 timer, and then we use a capacitor with a resistor to regulate the frequency that's output by the 555 timer. So we have 6 different potentiometers, so we were able to tune to the 6 different ideal frequencies that we needed when tuning the guitar. And when the user needs to switch between tuning guitar strings, we also put a dip switch into the circuit to allow the user to switch between which ideal frequency is going to be compared with the guitar signal. So the second part of this circuit is the microphone configuration. So this part of the circuit just takes the guitar signal from the user when they pluck the string, and it then comes over to an op amp right here, where the signal is amplified and also converted into a square wave. And then once that's converted into a square wave, the guitar signal will come over to our final part of the circuit, which is the frequency comparator. And this upper part of the circuit is the frequency comparator, which compares the guitar signal, which comes into here, and it compares it to the whichever ideal frequency we're switched to at that time. So once the two frequencies are compared, the difference between the two frequencies comes over to this op amp right here, and it amplifies the difference between the two frequencies. And then the beat frequency is then displayed on this LED light right here. So the farther that the two frequencies are apart, then the larger the difference between the two frequencies. So the beat frequency that's going to be shown on this LED light is going to be quite fast. And then the closer the guitar signal is to the ideal frequency, the slower the beat frequency will be output to this LED light. And then when you get the guitar signal just right on that ideal frequency, when they're exactly the same, then this LED light will stay stable. So let's do a quick demonstration. So right now I have it set for the high E string. So let's demonstrate real quick. Alright, so right now we're looking at the beat frequency that's output to the LED light. So we can tell that the difference between the two signals is pretty big because the beat is fairly fast. So as we get closer to the ideal frequency, the pulse is slowing down. So we know that we're getting closer. And if we give it the exact same frequency, we can tell that there is no beat frequency between the guitar signal